Welcome to this video. I've been getting a lot of questions on how to learn programming. So how to learn software development or how to learn programming. So I'm going to be tackling that in this video. So I'm going to just check through. I have some points that I've wrote down here, so I'm going to check them from time to time. So yeah, because I don't want to waste time, so let's just get into it. So point number one, it's mindset and motivation. So every time you have to try and challenge your mind to grow. That's number one. Be willing to learn. So, but this thing, I feel like it has got stages. But yeah, any stage you can be able to learn this. These some new technologies, some new techniques. So, and you have to know that learning to code is not a marathon, and it is a marathon. It's not a sprint. When you learn to code, and then you have to celebrate small victories, or by maybe displaying hello world. That's the biggest achievement. When you can be able to demonstrate that, and the steps how your program ran and what was happening behind, that's a big step one. And you have to have your why. Okay, I have my notes in front of me, so from time to time I'm going to check on them. So you have to find the why. What is exciting you, the motivation behind what is motivating you to learn, and also be willing to learn, focused on growing your skills, your knowledge. That's going to help you a lot. And then what problems do you want to solve? And then why will you keep doing this thing? What will make you keep motivated to code? Because at one point it's not about building a project. It's about, for me personally, it's about trying to learn and having some ideas. You run through some ideas, and then one idea you just learn this thing. You have to be consistent when you're learning. Whether you're doing 50 minutes per day or 30 minutes, it's going to be a good achievement, I promise you. And then you can start with basics for one programming. Choose one programming language, then learn the basics of that. The basics, for me, I started learning programming with C++. So the basics of learning, the basics of any programming language, they have basics. So, and they are the same. That's why I always try to say, learn one language. Firstly, it's data types, and then you move to control statements. Those are the basics. And also you have to know functions, the functions, like how to create a function. And then the function that is mostly famous on Java and C++, it is the main function. You must have that function. So it is the function that runs the whole program of your code. The whole program of your code, bruh. The whole code of your program, yes, that's the main function. And then you might have some other functions. There's also predefined functions for Java. I think also C++, they do have predefined functions. Then you can go to arrays are also basics. So you have to learn arrays. You have to know that arrays, the functions, also the structs, which is structure. And then you move to data structures and algorithms. Most yet we don't get there to data structures and algorithms, whereby you learn the data structure. So data structures like queues, stacks and queues. What is this? The queue. There's a lot of them, but I'm gonna list maybe the side of the side. And then the algorithms, there's lots of algorithms. I think it's binary search. Also there's also those kinds, sorting. Yeah, but if you know search and sort, every other algorithm is made of that. It's either it sorts or it searches. So if you know how to search basic term, when you search a number out of 10 numbers, out of 10 digits, then you can be able to create any algorithm that when you follow. That's the trick. And then if you create a sort, there's bubble sort, there's linear sort, there's a lot of sorting algorithms. But if you know the basics of sorting, whereby you say if this is less than this, then take this and take a temporal value, you put this, you take that temporal value, you put in there, and then you update that. That's a basic searching. That's a basic sorting algorithm. And if you learn that, you can be able to maneuver any other algorithm, and then you can know it. So, and then, okay, here there's arrays, lists, trees, graphs, sorting, searching. Those are algorithms. And then you can learn object-oriented. Those ones, they also need them in interviews. If you have to know the OOP concepts. And also every other language, they do have old concepts, they do have data structures and algorithms, but what's different is the syntax. So if you know the concepts, then the syntax is going to be different. When you go to another language, you learn a little bit, which is the syntax. You have to learn how to write maybe, for example, in Java we have a semicolon. There's TypeScript. You don't need a semicolon in TypeScript. Like, it's not going to penalize you for that. Those kinds, yeah, it's like that. Then for OP concepts, it's classes. You have to understand and know the creation of classes, objects, inheritance, polymorphism, and encapsulation. You have to create those things. So in short terms, a class is a blueprint. That's what our lecturer used to say. A class is a blueprint, and then an object is also an object. You create a class and then you have an object. What I normally do, maybe I will have this video next whereby we prepare for interviews. But what I normally do is have an example, even if you don't know the definition, but have an example. If you don't know it, just make an example. And how do you get the example? You get the example by knowing your code, because you have to keep on practicing and writing this code. So we have inheritance. Inheritance is whereby, okay, a class is whereby you have a car as a class, and then an object is whereby you name that class. Maybe the car is a Mercedes Benz. That's an object. And then you have inheritance. Inheritance is whereby you have this class that is a Mercedes Benz, but it can inherit. But you have these different cars. That is Mercedes Benz A class, C class, B class, S class. Those are child classes that are inheriting the base class. So you have this car as a base class, and then you have children class or child class, which is these types of cars that are inheriting the basic functionalities of this car. And then you have polymorphism. So polymorphism, what I've learned, and the easy way to remember it, is that poly means many, morphism means different structures. So it's many structures. Morphism, I think so. But what basically means is that you can change one class can do many things. That is a polymorphism. And encapsulation is whereby the data is being encapsulated. I think there's something else that I forgot, that is data abstraction. That is one of the OOP concepts. So classes, objects, inheritance, polymorphism, encapsulation, data abstraction. And then you have to choose now the programming language, which for me, we started with C++. We didn't have a choice, it was at school. So I would suggest people to start with because I want you to start with a hard thing. You can start with Java or C++. Some people love starting with Python so that you can get there. You don't have to know the syntax. You know you don't have to know this kind of syntax at first, but you know how is it working, the programming language, how is it working, what do you need to do, the base of creating this, because the programming languages are just tools to achieve a certain task, and then you have to know that. And then you can learn for web development. I feel like you should start with JavaScript, the vanilla JavaScript, and then you can move to the frameworks such as the React is a library, such as Angular, Vue, Node.js for the middleware, and then you can learn for data science, you can learn Python or R. And then for mobile applications, you have to learn Swift or Kotlin, Xamarin also, but preferably Kotlin, because Kotlin, you can convert your code from Java to Kotlin very easy on Android Studios. Then you have to have the learning strategies, like create a learning strategy for you. So the learning strategy is, number one, practice. Keep on practicing. Push every time. Try to study each and every day. Try to study. Set maybe 30 to 60 minutes a day to practice. More especially on Fridays, Saturdays, Sundays. You can learn something new and push. How do you learn? How do you keep on practicing? By having an idea. You can have this big idea of creating an e-commerce, but you need to start small. Start with For example, start with create a stopwatch. You can create a calculator. You can create a portfolio, which is you can create your website, about services, contact details. That is a basic structure. You can create that, and then what you can add the login details, the login system. Where then that's where things change. Whereby to learn, maybe you will need to know something before you will need to know something. Sorry, before you can implement that. For example, you on a e-commerce, you have to add a cart. You don't know how to add a cart. You don't know how to add the products, how to click that button, clicking, and then adding your products to the database. You need to know those things, and then you have to go on coding challenges like hacker ranks, elite codeware. But just when you are learning, that cannot take like more than 30 days or 15 days to learn. That's how, maybe if you are fast, 30 days is enough to learn those basics, learn the advanced, which is data structures and algorithms. And yeah, then you practice, then you build a small project, one small project, then you made, whether it's an e-commerce or you try to do a duplicate of Uber or Bolt or Takealot or Superbalist or some other application. You just do a duplicate, see how you can implement what you have learned, and then you can also, but contributing to open source, guys, I wanted to talk about it. I've never contributed because I don't have time. And then you can learn on online courses. I've learned on Udemy and I've learned on Code Academy, but yeah, you just need one or two courses, and then you can try to implement an idea that you have. It doesn't have to be like an idea that is never there, because it's very difficult to do that. Just get an idea, maybe create just a duplicate of something that is available. That's when you can learn about this thing. That's when you can learn. And then you go, when you are developing, for example, for me, for front end, I use Angular and TypeScript. What I do, there's TypeScript documentation and tutorials on the website, and then also on Angular, they have a clear documentation and tutorials there. You go there, you will never go wrong. You will never go wrong when you go there. You will have examples, you will have projects tutorial that was done. You also learn about their concept, and also they update Angular within 6 months. So yeah, you need to. And then you can get a mentorship. Someone who's going to mentor you, but like a mentor is not someone who's going to help you. I have to specify this or emphasize this. A mentor is not someone who's going to code for you. A mentor is someone where when you are stuck, you ran out of options, then you can go and ask. They can try and guide you. They are not going to come up with solutions. If your mentor is coming up with solutions, is developing on your behalf, that's not a good mentor. A mentor sits there with you, tries to guide you, questions you so that you can arrive to solutions. And also you can ask questions. I always say that when people want me to mentor them, you have to come to me when you don't have options. You cannot come to me because you want me to help you. It doesn't work like that. You want me to help you code, do this thing. It doesn't work like that. You have to learn on your own. Come to me when you run out of options. Let's say you are trying to debug. Come to me with that. I had a mentor in Cape Town where I was working that did help me a lot, but by just little time that we spent, he has taught me a lot about coding. When you try to debug, that's what he taught me the most, like debugging, how the steps of debugging. You have to start here, come here. Did you do this thing? Did you try the solution? If you did try the solution, it doesn't work, then you revert your code, you delete that, and then you try another solution. See if it works. If it doesn't work, you delete it. You go to the next solution. When you're Googling on Stack Overflow, you go through these step by step. When you're solving a problem, you are trying to debug, you don't copy this code on Google and then try to see if it works. And then if it doesn't work, you copy another code, you paste it. No, you take this code, you delete it, you take another code, you paste it, try to change that. But when you have an idea, you have to have an idea of what you are doing. As a full stack, I have to start on the front end, middleware, which is a back end, and then the database. Does the front end work? For example, I'm trying to return data to the front end. Okay, does the database work? Yes. Does the back end work? No. What is it not working? Then you try to debug there. You go through step by step. Does the data get into repository? You print that statement. Yes, it does. Does it get to the service part? If it doesn't get to the service part, you fix the service part. You try to fix the service. What are you doing wrong that that it makes it not to work. You try those solutions that you Google. You have this idea that you want to do, go and Google it. You take that link, you check what they are talking about. If they are talking about something that is similar to what you did, you take that, you copy it, you try to fix it according to what you want. You test it. If it doesn't work, and then you delete it. If it works, you try to enhance it more so that it can align with your code. Then you go to, if it doesn't work, if it works, you go to your controller. If it works, you test it on Postman. If Postman doesn't return data, then you check again. If Postman returns data, then you move to the front end. What is it that is not working? Definitely it's the front end. Then you try to fix the front end. That's how you break down the problem, the solution that you have. You take this problem, it's working. This part from the database to the repository, it's working. Where is it not working? Break that down. Remove the database now. Focus on the repository. It's working. Focus on your service. Is it working? If it's working, you move. That's how you break the solution down. This is the big solution, but you have these small pieces of code that you need to check on. Then you can fix the small problems. Also, when you are trying to debug and trying to have the solution, this big problem that you have, when you break it down, you write print statements. When you are trying to debug tests, you write print statement. Okay, it prints. That means it gets inside this function. So why is it not working? You try to work on that solution. Because sometimes the error, you cannot have an error, which is a syntax error. That syntax error will make your code not to run. But there's a syntax error, and there's two errors in coding, whereby your code runs, but you still have an error. It doesn't run the way you want. Then that's when you have this other kind of error. I just forgot what it is. Let me check. Syntax error. We have syntax error, and okay, we still have the syntax error and a semantic error. So a semantic error is whereby your code works, but there's some code violations there, here and there. You're not doing something correct. Maybe you missed, instead of saying if product is equal to this, you say if product is greater than this, then it doesn't work the way you want. Then that's when you can go through step by step up until you print inside that if. Does it print inside that if? No. Does it print inside the else? Yes. What is going on? Then you can check on your condition. That's how you can break down the step and up until you can work on your pseudocode. For you guys, I don't think I did write a pseudocode. Maybe that's why sometimes you find that I don't get to where I want to go. For example, I create this project. I have like 23 projects on GitHub, but unfinished projects, so I can't even show them. So I feel like those contribute because you don't have a pseudocode. You can't have flowcharts. You can't visualize what you want to do. You just have this idea on your head. Now, when it's time to debug, you can't scramble it, and you get demotivated. You don't finish. Those are things that okay. And then when you debug, I already told you, whereby you identify and fix the errors in your code. You can also use debugging tools, but the debugging tools I like on IntelliJ, whereby you can put breaking points. Yes, so yeah, that's literally that. You can like learn with that, and there's nothing much more. But wait, I'm gonna tell you at the end of this video, so you can continue learning, stay updated, like follow coding websites, follow on LinkedIn people who are talking about code, watch on YouTube people who are talking about it, attend events. What I'm gonna do this year, what I'm planning to do actually, to attend those events, AWS events, software developing events, like face to face, not on my computer or something. I have to go there, learn, meet people, Yeah, so that's what I want to do. Just be on the loop. For example, for me, I go to like on the web and then just learn, maybe get one article before I can sleep, and then you try to read and then you can sleep. And then lastly, you can embrace the challenges. You see, if you're someone who doesn't like to solve problems, I suggest you stay away from coding, because coding is all about solving problems. Have that edge of solving a problem, because that's how these videos on Instagram are created. These guys who say, it's just a small problem at 8 a.m. and then you are still sitting there at 8 p.m. You don't even feel that you're hungry. That's what happens when you love coding. You have to love the problems, solve the problems, because coding is challenging. So you have to tackle those challenges and problems. That's how you're gonna get to where you want to be. Lastly, never stop learning. So when you learn, you'll stay updated with this thing. So yeah, the last part was when I wanted to tell you about when you want to debug. There's this tool that breaks your code into, if let's say you have built your backend, your database, it's working fine. You built your middleware, it's working fine, which is the backend. Then you test with Postman. Postman doesn't return data. Then you can break those statements with this thing that is red. Then when you run your Postman, it's gonna break there, and then you can see, is the data that you are trying to send correct? Yes. Then you go further, which is you play your, it's play and pause. So you play, if it's going there, it's going there. Then also, is it returning the kind of errors that you want? If it's yes, then you're done. That is the nice part about coding. You have to learn. You have to be willing to learn. You have to be eager to learn new things. You have to enjoy challenges. You have to wake up and prepare to solve problems. Like problems, this is the last part I was going to talk about. Logic. In programming, computer science, logic is very, very, very important. Even it's important more than the code. That's why I always say to people, you want to learn coding, if your logic, you get your logic right, you don't even need to learn the code. You can just be on a group. That's why I always advise people that where I was studying, that also that you don't even have to know programming language or programming, but if your logic is intact, you know logic, then you're good to go, because that's what we need. You can follow a problem logically. We want to do this, then this, then this. That's when you can break your problems into small sub problems. Then you solve that sub problem alone. Okay, this part is working, let's focus here. That's how you can learn. That is the logic. You have to know the logic, which is sometimes that's what I used to struggle with. I know how to code, but I don't know logic. I can't think logically. So now that's when you thought, when I broke into logic thinking, which is the part of critical thinking, then everything was like easy. Now was flowing. Then you can search the syntax of the code. So now I started with syntax, learning syntax, and then logic. The easy way, logic, you know what you want to do, but you don't know how to code. You can go and search the code. That's the nice part. And interestingly enough, that's what robots cannot do. The logic and the human capabilities, they don't have them. So don't be scared about deving AI. Don't be scared about the AI that they are talking about. It's really not that much of a threat if you stay updated and learning. Sharp, guys. That's what I wanted to say. Bye.